Hello, welcome again. Today we are going to discuss the mesomeric effect. So the mesomeric effect is actually the polarity developed within the conjugated system by the complete transfer of pi electrons or non-bonding electrons due to the atom attached to the conjugated system. This is called the mesomeric effect. This phenomenon is called the mesomeric effect. Now I am going to write first the definition and after that with the help of suitable example I am going to clear this phenomena. Right? Now polarity developed in the conjugated system by the complete transfer of pi electrons or non-bonding electrons due to the atom attached to the conjugated system. This phenomenon is called mesomeric effect. For example, here is phenol, and in this is the conjugated system, benzene ring. Here is sigma bond and lone pair of electron present on the oxygen atom. So oxygen is the atom, or OH is the group attached to the conjugated system benzene, right? So here the atom attached is oxygen, and if you are going to delocalize the pi electrons, the next structure will be this, and here comes positive charge. So you clearly observe here the polarity develops within the conjugated system. So polarity develops because the lone pair of electrons or pi electrons delocalizes with the conjugated system. So it is the phenomena polarity developed in the conjugated system by the complete transfer of pi electrons or non-bonding electrons. So here the non-bonding electrons delocalizes benzene ring, that is the conjugated system, and because of that the polarity develops within the conjugated system. So this phenomena is called the mesomeric effect, right? Now move to the next point about the mesomeric effect. It is a permanent effect. Many times this question comes in the entrance exams, that it is a permanent effect or what. So it is a permanent effect. Mesomeric effect actually doesn't depend on the distance. It remains as such. The power of the mesomeric effect remains as such throughout the conjugated system, right? So it doesn't depend on distance and remain same throughout the conjugated system, right? Now the next point is, in this mesomeric effect the complete transfer of electrons takes place. So complete transfer in this effect, the complete transfer of non-bonding or pi electrons takes place, right? Now come to the next point. This phenomenon, mesomeric effect, is also like an electric effect, but the difference is in mesomeric effect the complete delocalization of electrons takes place, but in inductive effect the shared pair of electron is shifted. Complete transfer of electron doesn't take place in inductive effect. The second difference is the inductive effect is distance dependent, but in case of mesomeric effect is distance independent. So now write this phenomenon. Mesomeric effect also transmitted in the same way as inductive effect. But the difference is differences. First difference A, mesomeric effect is independent of distance, while inductive effect, I effect, that is distance dependent. Right? That means as distance increases, the I effect power decreases, while in case of mesomeric effect, it remains as such throughout the conjugated system. Right? Now next, in mesomeric effect, the complete transfer of electrons takes place, right? While in case of inductive effect, only shared pair of electron are attracted, right? Not complete transfer of inductive effect takes place, right? Now the next point is, in mesomeric effect, the electrons migrates from one end to another. Thus, some energy lost of the molecule. Thus, energy decreases, energy of molecule decreases, and hence stability increases. Stability of molecule increases. Right? So in mesomeric effect, the electrons migrates from one end to another, and in doing so, some energy liberated of the molecule. That means the energy of the molecule decreases and the stability increases. Right? Now next, move to the types of the mesomeric effect. Right? So the mesomeric effect is of two types. Right? So here, mesomeric effect of two types. That is, first is plus M and the second is minus M. So let's take the first one, plus M. So plus M mesomeric effect is when the electron displacement takes place away from the atom attached to the conjugated system. Right? So let me first write here, and then with the help of example I am going to tap it. When the electron displacement is away from the atom attached to the conjugated system, then this phenomena is called the plus M mesomeric effect, right?